Hi folks, welcome to another episode of NYC CNC. This is part 5 of the video tutorial on making the drawing dies to make copper jackets for bullets. We left off in part 4 with the part indicated in the 4-jaw chuck. What we're going to do in this episode is turn the outside. So we've got a smooth and concentric outside diameter, and then we are going to spot drill, and then bore the ID to, I haven't figured out exactly what dimension yet. Need to take a look at that. I'll talk through that here in a minute though. But first, before we make some chips, I wanted to hop back over to the CAD model and talk about a few ideas I had. So 2 things in the CAD file. First, let's take a look at our dimensions now that we've got the correct size to get the jacket diameter we want. The yellow punch piece here will be 700 thou, and then the bushing that it will slip in will be 701. In other words, just enough for it to slip through. We can hide this now. And then the ID of that will be 520. We'll worry about that in another episode of the video. And the ID of the bottom half of the die body will be 704. So the difference between the 700 and the 704 clearance is for a proper shear. The other thing I wanted to mention, we can go ahead and hide some of these other pieces here, is this idea of how to extract the formed cups from the punch. The idea I had in the previous video is to let them stack up and eventually they'll just come out the top here like so. That's fine, that will work, and that may be the plan in the end. But what I started experimenting with last night, and it's by no means a fully baked solution, but I thought I'd throw it out there, is cutting a window of some size partway up the punch, just like you see here, and then the punch ID would obviously step to a wider ID as you see here, so that the punch, so that the cup is now free inside of here. But then the issue is, how does it strip off the actual punch itself? Remember, this will be all one piece. So my idea is some sort of a moving piece like you see here that will push out of the way as the yellow punch comes down, but then to strip the cup off of the purple punch, it would have a spring or some kind of mechanism, haven't figured that part out, that when you then pull this down, it would hold the cup in place, and once you pull this down below, you've now got a free jacket that will then fall, not a jacket, but a cup that can then fall out the little hole here. I'll think more about that. It's a work in progress, but wanted to share at this point. Last thing I wanted to do while we're at the computer, pull up GWizard. If you don't have GWizard, great piece of software, highly recommend it. It's my go-to. We wanted to get a rough RPM for our drilling operation. So I selected the low carbon steel, and then from the more option, I picked the specific 1144 high speed steel twist drill. We'll start with a 1/2 inch drill. That's going to be 537 RPM. Then what I like to do is think, just to get a sensitivity for speed changes, if we jump to a 0.6 inch drill, or approximately, you drop down to 458. We don't have an infinite variable speed. We've only got a gearbox on our Emco, so we're a little bit limited, but it gives me a very good idea of where to start, and I'll handle the feed rate in inches per minute just by feel on the tailstock. Okay, let's come up and get our tool set. We're going to take a very light cut just to clean up the outside and have the concentric OD. So that's 0. I'll take about 10 thou per side, so that's a 20 thou cut. And we are going to spin her at about 700 RPMs in our gearbox. And let's get some cutting fluid ready. Okay. Yeah, we're just barely hitting the outside of those socket head cap screws. Not going to hurt anything. Okay, turning her real slow, Just looking to get a good surface finish here. In fact, let me try to move the camera here. Hold on one second. Okay, there you can see the cutting edge a little better. As I mentioned earlier, this 1144 is apparently known for not building up bird's nests. It chips real well, and actually one of our viewers mentioned they use it a lot in automatic turning centers so that you don't get bird's nests and mess up automatic parts with, you know, machines that are run on bar stock feeders that don't need a lot of babysitting. And sure enough, as you can see here, this stuff doesn't form any sort of a chip, or any sort of a string chip at least. Give you an idea here of our turning speed. You can see the power feed here running pretty slow. Just about ready to kick her out. I'll give it one last bit of oil. Good enough. Okay. Let's actually wipe her off with a paper towel. See what she looks like. Great. That's awesome. Now, mostly because I'm new to this machine, and I like kind of experimenting and playing around as I get to learn a machine, let's put our indicator back on there and see. Right now, the readout should be just absolutely dead nuts on. There should be no play. Let's see if that holds true. Okay, let me get the camera focused in here. Remember, this is the tenths indicator, so the 1 mark is 1/1000th of an inch, with each tick in between it being 1/10,000. Probably a false level of precision, and you know, you breathe on this thing and it moves. That's a thou over. This whole setup isn't, you know, this isn't a high quality one, nor is it rigid, but let's see nevertheless what happens. Perfect, just as I expected. Because we just turned this, there is no run out. Pretty cool. Okay, let's get our spot drill set up here. On an Albrecht chuck, you never want to have the butt of the drill bit against the inside floor because that floor moves as you tighten it. So you want to have it spaced off just a hair. And we'll get some cutting fluid ready on the part. We want to go real easy on this. Actually, I say we want to take this easy and be accurate. The truth is we'll get our accuracy from our boring, not our drilling. But nevertheless, let's do this as smart and as careful as we can. Okay, we got our speed set. We'll bring our tailstock up here to approximate. Tighten that down and let's go. Looks good. Forgot to mention, before I started the camera, I checked, rotated my chuck by hand, and I actually set the backstop against the carriage so that you don't knock your carriage into your chuck jaws. That's not good. Okay, that looks great. Let's go ahead and start with a drill bit. This one is a 29/64. It's in slightly better condition than my 1/2 inch, which is why I'm using it. And one thing I wanted to mention on drills, you drill a lot, or you do a lot of either important work or, you know, work where you don't have, with quick turnarounds, keep 2 sets of drills, either 2 complete sets or keep extra drills separate in a separate container, preferably in a toolbox or somewhere put away, that you always know are in great condition, that you can always go and grab it and know that it's good. Too often what happens with the drills that are out on the shop floor is they get dinged up or they're not sharpened, and when you really need a good one, something like that's good to know you've got one. Okay, so what we want to do is pay attention, because when the drill moves into the body, it shouldn't jump around on us, but I just want to be careful so that as it hits that gap, it wouldn't walk. Again, it's too small of a gap for me to be that concerned about it, but nevertheless, that is the money. It's too small of a gap for me to be that concerned about it. Plus, like I said, we will get most of our accuracy from our boring, not from our drilling, but nevertheless, I do want to pay attention to what's going on here. Okay, a little bit of lube. And we'll take this slow, mostly because, again, this machine is new to me, and the material as well. Okay, now I'm past the center drill. Back out and get some coolant in there. In fact, I'm going to start back a little further, give myself room to get coolant in that spot. Try to be smooth with the tailstock handle. Okay, I just broke through. Nice and easy. I'm starting on the downside. Okay, let's back out. I don't want to create any rubbing or generate a bunch of heat by not clearing the flutes out. And you can see from the smoke that that drill bit is hot. Okay, now let's start paying attention. The drill bit is at 1 inch on my tailstock. We know that that's about 3 inches exposed. So let's see how far we are, just ballpark. Okay, I'm at 2.5 on my tailstock, so we're only 1.5 inches into the part. And I've got to take it slow now because those the flutes on the drill are building up quickly. Okay, let's double check that math. Yep, we're at 1 inch. So we're starting at 1 inch in, so there's 2 inches, which means we're 1 inch into the hole. 2.5, so we're 1.5 into the hole. Okay, there's 3, so that means we were 2 inches approximately into the hole. Okay, let's take a break and see how we're doing. Okay, part's pretty warm. Not worried about it, but it's warm. Hasn't moved on us. Our dowel pins are good, and our screws are tight, so that's great. If it moved, you'd instantly feel it on that line there. Take a look. Okay. Surface finish inside the hole is, as expected for a drill bit. So these are stubby drills. So let me take a look and think what I've got, because I really want to use a jobber length drill here. The only jobber length I've got is a number set. So Z is the largest number. Z drill is 413. So it's a little bit smaller than what we were just using, but that's okay. What we're going to do also is just simply, we want to make it through our body that we turned down. So we're basically going to want to go all the way into the last little bit of the flutes there. So let's get it chucked up, and we'll hopefully make quick work of this part. It's interesting, this steel is actually harder to work with for drilling because it doesn't form a string chip that would naturally ride its way out of the drill flutes. These small chips just build up. Obviously not a problem if you've got a through spindle coolant system on a turning center, or even a high pressure coolant system. Let's switch to our next bigger drill bit. Now we're going to drill with a 5/8 inch reduced shank Triumph drill bit. This is a really nice, high quality made American drill bit. However, what I would rather have done is had a drill bit that went straight into the Morris taper shank of the tailstock. I don't have a set of those, so we're going to continue using the chuck. You just got to be careful. You don't want to spin these in the chuck. A little bit of cutting fluid. And we're going to slow this down. Okay. First time I saw a real chip form with this stuff. I'm putting coolant all over the drill bit just to try to keep the temp down. Obviously, it doesn't do any lubricating up there halfway up the flute. Same thing, I don't want the flutes packing up and rubbing or generating heat, so we'll take our time. Let's just take a look and eyeball how deep we should be. Okay, so again, we're going to be basically taking up all the flute in the drill to reach our bottom of our hole. Okay, one more should do it. Okay. Let's take a look inside. Okay, here's a new camera angle. Let's see what we got on the hole. Okay, looks fine. Don't feel any ridges or problems or anything of the sorts. And take a look at our boring bar. It'll be tight, but that will certainly fit. So let's get that set up. Now that we turn this OD, we want a match mark, so we always put this together the same way. So using an automatic center punch, I'm going to just put 2 dimples in here. I would never do this with a hammer for fear of damaging the chuck or the spindle bearings, but an automatic center punch isn't going to hurt anything. Now for our boring bar, we won't be able to go any further than, just a hair short of the shank here, and that'll take us well into the bore of the second part, so that's fine. Remember, all I'm trying to do here is get a concentric and smooth inside finish here. Drills do not drill good finish or even round holes. Whole other subject on that. But let's set this up and take as light a cut as we can, because remember, if you saw in the CAD drawing, we do need a shoulder in here or a step of some kind. There are a lot of ways to skin that cat. The priority is a smooth bore, and then we'll worry about the design and the geometry there. Before we bore though, just for kicks again, let's throw our indicator on here and just see if the pressure or heat or anything from drilling moved this part. I'm not going to move the camera here. We're just going to take a quick look at this one. It's still right where it should be, which is what I expected. Now, I am no boring expert. My 7x14 lathe didn't bore that well, at least with the equipment and experience I had. Anyways, this machine has been great, the little bit I've done with it, but I just don't have as much experience. Not that it's a particularly complicated operation. One thing I will mention that I understand is that you can run a boring bar a little bit above center, and we're going to have to raise this up here a little because we need to clear the bottom of our boring bar. And actually, we can clear the bottom of it in this instance and still be on center. Okay, that looks good. What I do is I just run it in all the way just to make sure you're not going to hit anything, just to be safe. Good. Okay. I'll start with some cutting fluid, but then I like to use the air hose because I think that does a better job of blowing the chips out, which is to me more important than coolant because I don't want chips rolling over on themselves, messing up my nice finish. The other thing I wanted to mention is, oh, just a silly point, but making these videos, which I love doing, the one thing I have to keep in mind, just so you understand, is that I've got to get the camera in a place where it's safe. I always need to be able to hit the e-stop or move around and not trip or fall. So sometimes that's why this gets a little complicated. Okay, let's get the cutting fluid though on here, and we'll be underway. Okay, like I said, I'm going to come in here, make sure I'm not touching, then we'll start the machine. Now we're going to back out until we just touch. Okay, and then we'll take, a 10th thou cut. Here we go. I just heard it break through our slot there. I'm not seeing the chips come out, which has me a little worried. Okay, that's all we're going to take. Move it in. I'm not particularly pleased with the surface finish. As you can see, it starts off smooth, but I can see ridges in about a ½ inch deep. But rather than worry about that, it may not be a problem, because what we really care about is to see if we've got something concentric. And then we can worry about the quality of the surface finish on the boring as we do these parts separately. So let's get a test indicator in here. FYI, this is a ½ thou for every tick. Good. No run out at all. Okay, so the question is, am I taking a risk in that there's bad enough surface finish in the start of the bore or the lower part? So the way to solve that, I just realized, is let's just take this top piece off and then we can see what the finish looks like on this one and maybe just bore it separately right now. Okay, maybe I'm being too harsh on myself on that surface finish. But again, let's grab our indicator and see what she reads. That is what really matters here. Okay, here's the big test. Perfect. Little bit, you can actually see the vibration in the needle. That is from the surface finish. So I don't love that, but what matters is I can re-indicate this part as needed and wouldn't have any problem getting it centered. However, that's a moot point because I'm going to wrap up part 5 right now, and on part 6 what we're going to do is come back and bore this to the final ID. If you like this video, please give it a thumbs up, share it, comment below. If you're interested in seeing more of the behind the scenes, check out the Facebook page. Otherwise, I'll catch you later. Thanks, folks.